without wasting any more time, I would like to call our facilitator, Rishabh Mehta, who is our current GDSC lead for PHCET, to start this session. Over to you, Rishabh.
Okay, so very good evening, everyone. I would like to welcome you all to the day one of Android Study Jams conducted by Google Developer Student Club PHCET. The agenda for today's session is to kickstart our Android journey by learning about the fundamentals of Android. In today's session, we are going to start by knowing more about the Android Study Jams, and there are some instructions that I would like to clear once again, and then we can start with Android. I will start by introducing myself to you all. So hello everyone, my name is Rishabh Mehta. I am the founding lead of GDSC PHCET, and previously I have been a developer intern at Cantilever Labs and Fine-Tune Solutions. And I'm going to be your facilitator for this year's Android Study Jams. And throughout the next 30 days, while we all complete this course, feel free to reach out to us if you get stuck somewhere. Talking about my interests, I am very much passionate about Android app development. I had started my app development journey in Android by using Java as the programming language, and later on, I switched to Kotlin. We will talk more about Java and Kotlin later on in this session. For now, let's get to know more about the Android Study Jams program. So, Android Study Jams are the series of workshops and sessions that are organized and facilitated by us for the members of GDSC PHCET to kickstart your learning journey on modern Android application development using the Kotlin programming language. You will learn about how to develop functional Android apps using the best development practices, and you will also learn about how to work together on Android projects with other developers, and also how to contribute to open source projects on GitHub. So now that you know more about Android Study Jams, let's get you started. And I hope most of you all have already done these steps following the PDF that was shared on WhatsApp. But for the people here who might have not yet done it, I will briefly give you the instructions. And don't worry if you are not able to follow along. You will receive the recording of the video as well as this PPT as a PDF on the WhatsApp after the event. So all you have to do is go to this link, and then you have to sign in and create a new account. This is the website for Google Developer. So you just have to create your own developer profile. And once you have done this, you just have to go to settings. You just have to go to settings and change your privacy setting and make your profile public. That's all you need to do. And then your developer profile is set. After this, you just have to go to this link, g.co/android/basics. You will receive this PDF later on our WhatsApp group. So this is the link for the course that we are going to follow. And this is the course that we are going to complete on Android Study Jams. So let me take you through it. So this course consists of 6 different units. Each unit covers a fundamental part of the Android application. So these are the 6 units that you are going to cover. And in total, there are 16 pathways. Now, what do I mean by pathways? Now let's open the unit 1. As you can see, every unit consists of pathways. So for example, the unit 1 has 4 different pathways, and each pathway consists of activities. So you just have to open every pathway one by one, and you have to complete different activities. It can either be videos or code labs. So you just have to watch the videos that are here. And after that, you have to just read the code labs and take all the notes. So you just have to read the code labs. And once you are done, at the end of every pathway, there is a quiz. You have to take this quiz. And when you pass this quiz, you will receive this Google Developer Badge. So for every pathway that you complete, you will receive a developer badge. So in total in this course, there are total 16 badges, or as you can say, there are total 16 pathways that you need to complete in the next 30 days. So once you complete all the 6 units, you can go to your developer profile and you can track your activities here. So you will get a list of all the badges that you have received. So when you complete the whole course, you will receive a total of 16 different Google Developer badges here. And once you get all the badges, you will receive the certification for completing Android study jams. Please note that you have to complete all of this before the 10th of January. Now, what are the expectations from Android study jams? Now, as a participant, what you have to do is complete all the 6 units. That is a total of 16 pathways. Doing this will earn you 16 Google Developer badges that will be visible on your Google profile. Along with that, once you complete all the 16 pathways, you will also earn the Android Developer certificate. And all the people who will complete this course, they will also get a reimbursement for the Associate Android Development certification from Google. More on this will be shared later on during the end of the Android study jams in January. Okay, so the prerequisites. Here are some of the prerequisites for the Android study jams that will be helpful. You need to have basic computer literacy, and the knowledge of any of the programming language like C, C++, or Java would be very much helpful. Now, apart from this, you will need a computer or a laptop on which you can run Android Studio. You don't need to have Android Studio to complete this course, but to make the app and practice it by yourself, you will need Android Studio. Apart from this, you need to have an Android device that you can connect with your PC or laptop, on which you can run the Android apps that you make. Or if you don't have Android device, you can even use the emulator along with the Android Studio, which I'll show in a little bit. Learning objectives. So let's talk about what you will learn as the part of Android basics. First and foremost, the goal is for you to build your first Android apps. To do this, you'll install Android Studio on your computer, which is an application used to build Android apps. Along the way, you will be exposed to programming concepts and the Kotlin programming language. At the end, we will also be talking about resources on how you can continue learning and building apps beyond the end of this Android Study Jams event. So let's start with the first topic. What is Android? Android is an operating system that is based on the Linux kernel. For those of you who don't know much about what a Linux kernel is, for now, just understand that it acts as an interface between the hardware and the software. So Android is based on Linux, and hence it is an open source environment. Now, the Android operating system covers more than 80% of the global smartphone market. And hence, if we as a developer are making apps on Android platform, we are already targeting more than 80% of the smartphone users. We now have different ways to connect our Android, not just in smartphones. Android powers smartwatches, Android TV, car OS, and many IoT-based devices as well. As of right now, there are more than 2 million different developed and signed applications published on the Google Play Store. So as you can see, there are a lot of apps, and the user base is also large for the Android ecosystem. And Android is highly customizable, as Android devices come in various shapes and different sizes, from watches to smartphones and big tablets to huge Android TVs. So we as developers can customize the user experience based on the Android device specification. The software developer kit. Android SDK is a collection of libraries and software development tools that are essential for developing Android applications. So it is a set of tools that is used to develop Android apps. Now, whenever Google releases a new version of the Android software, like from Android Lollipop to Android Marshmallow, Android 10 to Android 11, with every new release of an Android version, the Google also releases a software development kit for that Android version. So with every new Android version update, we also receive a new version of the SDK. So what SDK does is it adds the new features that we can implement in our Android application. So it is for the developers. Now, Android Studio. Android Studio is the official IDE for Android application development. Now, as the SDK that we talked about earlier, this Android SDK is inbuilt in the Android Studio. So Android Studio is bundled with the Android SDK that we just discussed earlier. Android Studio consists of a lot of things which cannot be explained here in this presentation. So what I will do is I will show you how you can download it and install it, because you will be needing it later on when you will develop your own apps. So I'll just show you how you can download and install, and then I'll open my Android Studio and give you the overview explaining all the major components of the Android Studio. So you can just go to developer.android.com/studio, and from this link you can download the stable version of Android. I would highly suggest you to use the stable and not the beta version, because then you may face many errors that will be very problematic. So I would highly suggest you to always use the stable version of Android Studio. Using this link, you can just download the Android Studio and complete all the process. If you have any issues, you can ask me, or even you can see many videos about it on YouTube about how you can install it. So it is not a very hard process. It is very easy. One thing that you need to keep in mind is you need to check the system requirements to see if it will work on your laptop or mobile phone. So once you are done with it and you have installed Android Studio, this is something how it will look like. I have just opened one of my project to show you how Android Studio looks. So this is the overview of the Android, and I will be explaining all the different components a little later on in the presentation. Let's move back to the presentation for now. So the next thing is Google Play Store. Google Play Store is a digital distribution service. It serves as the official app store for certified devices running on the Android operating system. For the Android users, it is just a place to download apps. But for Android developers, Google Play Store and the Google Play Developer Console is a place through which you can digitally verify and sign your Android applications, which you can later release to the Google Play Store for the people to download and use your app. There are a lot of more detailed features about Google Play Store and the Google Play Developer Console that we are going to talk about later on, because it is out of today's agenda. So later on, at the end of the Android Study Jam sessions during the start of January 2022, we will be learning more about how to publish your Android apps that you develop to the Google Play Store. And that is the time when we will be taking a look at the more detailed feature of the Google Play Store. Android architecture. So first of all, before we start with the Android architecture, I will just like to say to you all that there are a lot of things that I'm going to say right now. And if it does not make sense to you, or if you do not understand everything, it is completely fine, because this is not something that you need to know in detail when you are starting up with the Android development. You just need to know the basic details about the architecture and what it is, but you don't have to know it in complete detail. So even if you don't understand everything, it is completely fine. So the Android architecture contains different number of components to support any Android device needs. There are 5 different layers of the Android architecture, as you can see in the diagram. Let's start with each layer one by one and know a little bit more about each layer and what it does. So the first layer you can see is the system apps and the user apps. So about system apps, Android comes with a set of core apps like for sending emails and SMS and calendar, the internet browser and the contacts app, settings app, and so on. So these system apps are pre-installed in our Android device in a read-only file. So these system apps cannot be deleted by us as the users. So these are inbuilt and it cannot be deleted because it is stored in a read-only file in our ROM. Then there are user apps. So these are the apps that you can download from the Google Play Store and use on your Android phone, like for example, WhatsApp or Instagram or any other apps that you download from Play Store. These are the user apps. And the system apps are the apps like, as I gave the example, the phone app or the email app or the internet browser settings app, and the things that you cannot delete and come inbuilt in your Android device. The second layer that you see is the Java API framework. all the features of Android that are available to us are available through the APIs written in the Java language. Like for example, the UI elements such as the buttons, the different views that we will learn on later on in the presentation. All these things, they are written in the Java API framework. So this is the second layer. The third layer consists of native C++ libraries and the Android runtime. Now, many core Android system components and services are built from native code that is based on libraries written in C and C++. So that's why these C++ and C libraries are a part of the Android architecture. Now, you all might know the names of different Android versions, but like for devices that run Android version 5.0 and above, that is the Android Lollipop or above versions, that is almost all the Android devices right now. In Android 5.0 and above, each app runs as its own instance and as its own process. Like for example, how I can say, each app runs as its own virtual machine in the Android operating system using the Android runtime. So every app that you launch, it has its own process. So for example, if a single app crashes, it will not crash the whole Android operating system. Like you might have experienced when some app crashes, it does not, your system does not get crashes, and it is not like your Android will reboot. So that is the purpose of Android runtime. It makes every app run its own instance or a virtual machine on the Android operating system. The fourth layer is the hardware abstraction layer, or HAL. It provides an interface through which we can use the hardware devices on our Android system, like the camera, flashlight, the Bluetooth module in our Android phones, the microphone, and the speaker of our Android devices. So the HAL provides a surface, an interface that through which we can use these hardware devices. And the bottommost and the most important part of the Android architecture is the Linux kernel. Now, as we saw earlier, the Linux kernel acts as the interface between the hardware and the software. And it is the foundation of our Android platform. And it is the most important part of the Android architecture. Now, as I said earlier, even if you don't understand much about each layer in detail, it is completely fine. You don't have to think much about it. You just have to know the basic details about the architecture and what it does to know more about Android. Now, let's move on to the next topic, Android versions and API level. Now, as we were talking earlier, the Android operating system, it is the different versions of Android operating system are denoted by three different things. One is the Android version number that you can see on the left side, like 4.0, 4.1, 4.2, 5, 6, 7, 8, and so on. Then there is the Android version name, ice cream, sandwich, jelly bean, lollipop, marshmallow, nougat, Oreo, and so on. So these are the two things that most of us are aware about, the Android version number and the Android version name. It is also available in the settings of your Android device. The third thing that is more important to us as developers is the API level. So as you can see in the number 4.1 and 4.2, these both denote Android Jelly Bean. So we cannot use the name and numbers to denote it clearly in the development perspective. So for the development perspective, we use API levels to denote every Android version. Every single Android release has a different API level. And in development, we use API levels. So just remember it. From now on, we will be denoting every Android version using the API level. For example, like if you want to talk about the Android Pie, or if you want to develop a single feature for the Android Pie users, we will be using the API level to denote it, the API level 28 and so on. And this cumulative distribution tells that how much percent of Android devices will support the feature. For example, later on, you will see when I show you that when you start a new Android project, the Android Studio asks you that what is the minimum Android level that you are targeting for your app. That is, what is the minimum level of Android that your app will support. So this is called the target API level. So if you set your target API level to 21, that means you are covering 94% of all the Android devices in the world. So your app will support 98% of all the Android devices. For the current time being, it is recommended to use the API level 23 as your minimum level. And it is also the default setting in the Android Studio as of now. So it covers 85% of all the Android devices, and almost all the devices that we all use right now are above Android 6.0 and above. So this was all about the versions and the API levels of Android. Now, what is an Android app? Now, an Android app consists of a lot of things. What we define an Android app through is that it has one or more screens. So every Android app has one or more interactive screens. Now these screens can also be called as activities or fragments, which we will be learning later on in detail. So an Android app has one or more interactive screens that are connected with each other. It is written in Java or Kotlin programming language and uses XML. Now, what are the purpose of these? So earlier, Android used to be only written, Android apps used to only be written in Java programming language. And recently we have shifted more towards the Kotlin programming language. So Java and Kotlin are used to build the logic and the backend of our Android app. And the XML file is used to write the user interface of our app. You can use the analogy of the web development field in this. So XML serves the purpose of the HTML that we use in web development, and Java and Kotlin serves the purpose of the JavaScript that we use in the web development field. So every Android app uses the Android software development kit. So every Android app is developed using the SDK, and it uses all the Android core libraries and the Android application framework. Also, every Android app, as we talked earlier in the architecture, every Android app runs on its own instance of the Android runtime, that is a virtual machine. Now, the challenges that we face in Android development. As we talked earlier, Android is a vast ecosystem. So Android devices come in multiple screen sizes and resolutions, from 5-inch screen to 6, 7, 8-inch and big tablets and Android TVs and so on. So Android devices come in a lot of different sizes and resolutions. And hence, the first challenge that we face is whenever we are developing an Android application, we have to make sure that our application or the user interface that we design, it suits all the different screen sizes. Like if, for example, we are designing WhatsApp, so the design of the WhatsApp, or for example, a login screen, if we are designing a login screen for Instagram, so the login screen should have the same user experience, and every element should be present in the same area or the same relation with each other in a small screen, as well as the large Android TVs or the large tablets. So this is the first issue that we face as developers, that we have to be more cautious and we have to program according to different screen sizes, keeping them in mind. The next issue is performance. Now, as Android devices come in different screen sizes, similarly, according to the different developers of the Android devices, based on the company that produce that device, it can vary in the performance. Like for example, different Android devices can have different RAM sizes, different processors and so on. So the performance can vary from one device to another. So we also have to keep in mind that we don't run a lot of background services in our apps, and we have to keep in mind that it will run smoothly and similarly on every Android device that we are targeting. Then for the similar reason, security is also an issue. Then compatibility, as Android gets a new version update every year, we have to make sure that the app that we are making, it covers a lot of Android versions. As we saw earlier here, we have the more older version in Android that we cover the more number of users. So we have to make sure that the app we make, it is compatible with a lot of different Android versions and a lot of different Android devices. The next topic is Android building blocks. So now I'll just go back to the Android Studio and explain you one by one all the elements. So this is the file structure of the Android app. So the first thing that you see is in top, we have the panel of different options here. And then in the left side, we have the navigation panel, and here you can open all the files. So this is the this is the file of the current project. And in the left side, you can see the file structure. So let me show you something. So there are a lot of different types of files in every Android project. So this is the basic skeleton of what an Android project structure looks like. First of all, let's talk about resources. So we have layouts that you will see later on in the presentation. And then we have XML files. And there is a file called manifest. So what manifest is, the manifest file has the information about our Android app. So all the information that we need about the app when the app starts running, that is present in the manifest. You can see the manifest file here. So all the basic information about our app, like our logo, app's icon, the name of the app, and the other information like the theme that it is running, the information about all the activities or all the different screens that are present in our app, and so on. Like all the information that we need before we start running our Android app, that is present in the manifest file. So this is the purpose of the manifest file. It tells the Android runtime what all things need to be rendered first. So after that, for every different Android screen, there are two files, as we talked about. One is the Java or Kotlin file that has all the logic, and the second is the resource file. So as you can see below the Java folder, there is a resource folder. And in resource folder, as you can see, there are different attributes. There is a color file in which we can define different colors that we are going to be using our Android. Then there is a drawable file. So drawable folder. So in drawable folder, we can define different elements, the UI elements that we need to use in our Android app, like a checkbox or different buttons or different user UI elements. We put all the UI elements in our drawable folder. Then we have the layout folder, and this is the thing that we need right now. So as I was talking earlier, every screen on your Android, it has two files. One is the Java file and other is the XML file. So for example, I have a screen called screen named all.java. So in this file, it stores all the logic and all the backend of that screen, the purpose and the code. And the all.xml file, it contains the whole user interface of that screen, the whole UI. So every screen in Android, it has two different parts. That is a Java or a Kotlin file, depending on which language you are developing in, and an XML file, which has the user interface. Don't worry about the code. We will be covering all of these things later on. Now, so this left panel, now you know, it shows the project structure of our Android app, and we can locate and navigate to different files through this. Then the middle screen is the development area. In this area, we can open any file and we can edit it. For example, if I want to make changes to this Java file, I can just open it here and do all the changes in coding here itself. And similarly, we can do with our layout files. So for the user interface, we can make changes here. So this is the editing area, the center one, and you can open and navigate between apps here. Then in the right side, let me open something else. Okay, so in the right side, you can see this is the UI panel here. In the UI palette, there are three different options. One is the design, then split, then code. So it is based on you. If you just want to drag and drop the different elements of Android, like a button or image view and other things, you will be seeing this later on. So you can just drag and drop in your app here using this, or you can have a split view. So you can just code things here and you can see what all changes it will make to that screen. And the third is the codes, just the code screen. So if you don't want to see the design and just want to code, you can use this. Personally, I prefer using the split screen because when I'm making the user interface, I can see all the changes that it will be doing to my screen. So this is the three things. And Then here you can select the emulator. So if you don't want to connect your Android device and run things on that, you can use a emulator that is present in the Android. We will get to it later on and we will see about it more in detail. Let's get back to the presentation and continue to the next topics. Okay, so I missed this. So one more thing about this is, now you saw the layout strings and colors and XML file and so on, and Java and Kotlin file. Then now you know what is the purpose of a manifest file in our Android project. Then there is another thing called build configuration, that is Gradle file. Is there in the presentation later on. We will be covering this. So these are the Gradle scripts. There are two different Gradle files in an Android. One is the app level Gradle file and one is the project level Gradle file. So what Gradle file is and what is the purpose of the Gradle file, we will be covering later on in the presentation. So after that, there are the components. So this is an important topic, so please pay attention closely. So let's cover these things in detail. Now we are done with the resources, manifest and build configuration. Build configuration will be taken care of later on in the presentation. Now let's jump to the components. So the first component of the Android is activities. So what are activities? So like earlier I was talking, activities are nothing but the activity is an application component that provides a screen with which a user can interact or do something. So every different types of screen that you see on your Android device, everything is an activity. Like if you open a WhatsApp, or if you open the Instagram and you have a login screen and so on, every screen that you see on an Android app is called an activity. So this is activity. For example, the contacts app is activity. Then you are on a login screen. This is also called activity. So in Android, we don't call it screens or different web pages like we call in web development. Every screen that you see is an activity. So about activity, every activity has a life cycle. So what do we mean by that? So as I was talking about earlier, activities is nothing but it is a screen that a user can see on an Android device. So the next topic is activity lifecycle. So when a user navigates through your app, like when he goes from one screen to another screen, the activity transitions from one state to another. So there are different stages that activities goes through, and you need to know this life cycle, because for the features if you want to develop many features in your Android app, you need to keep these things in mind and you need to develop accordingly. So the first state is on create. So in on create state, this is the state when the activity first gets called. For example, you are starting Instagram. So when you click on the Instagram logo, the home page activity gets called and it is created. And then the next function that gets called is the on start. So this is the second part of the activity lifecycle. So this is the callback that is called when an activity becomes visible to the user. So you click on your Instagram app and the home screen starts. Home screen starts. So this is the started phase of the activity lifecycle. Then the third part is on resume. So this function is called when the user starts interacting with the with your app. So let's recap. On create function is called, for example, when you open your Instagram app. Then on start function is called as soon as the screen is visible to the user. So it is in milliseconds. And then on resume function is called as soon as the user starts interacting with the app. So let's say I'm scrolling through my Instagram. So that is the point when the on resume function will be called. So now let's say I click on say something and a pop-up comes in my screen. So when a pop-up comes to my screen, at that time, the background activity, that is your home activity, gets paused. And when your home activity gets paused, or like, for example, you are using Instagram and you get a call. So as soon as you pick up the call activity gets in front of your app. So at that time, your background activity, that is your Instagram homepage, it gets paused. So that is the time when on pause is called. And the next stage is the on stop function. So it is called when the activity is no longer visible. For example, you move to your profile page on your Instagram. So when you move to your profile page, your home page activity gets stopped. So that is the time when on stop function is called. And then, for example, if you close Instagram, so when you close Instagram, that is the time when the activity is destroyed. So that is the time when on destroy is called. So why do we need different life cycle for our activity? So that we can implement different features for different time. So for example, you are making an app for users to give tests. So you want to make sure that no one cheats in that test. So what you can do is you can make a feature in the on pause function that as soon as the screen pauses, the test will end. So how can you implement that? You can code that part in the on pause function. So whenever the activity gets paused, for example, if the user is switching from one app to another, as soon as that event happens, the on pause function will get called and the function that you designed will occur. So this is just an example of how you can use different functions. So later on, when we develop app, we will get to know more about this. And just like if you have developed app, if you have written program in C, C++, or Java, in C, C++, and Java, we have the main function. And the purpose of the main function is that we write all the code in our main function. Similarly, in Android Studio, even though we are writing the code in Java or Kotlin, there is no main function. We write our code in the onCreate. So I'll just show you here. So like for any screen, you can see here clearly, the onCreate function is here. So there is no main function in Android, even though we are writing a Java code. This is just an example of that. Now let's move on to the next topic now that we know what an activity is and about activity life cycle. The next topic is services. So services is the second component of the app building block. Now, what are services? So a service is an app component that can perform long running operations in the background. So it does not provide a user interface to the users. And once it gets started, a service can continue to run in background for some time, even if the user switches from one app to another. So for example, so there are two types of services: foreground services and background services. So the foreground services are the services in which some operations can be noticeable to the users. For example, if you are using an an audio app, for example, if you are playing music on Spotify, so the audio track that you are playing or the song that you are playing, it continuously is synced from their servers using the services. So you can see you can hear the audio playing and you can see the progress bar going on. So this is the example of the foreground activity that is visible to the users. There are also the second type is the background services. So the background services performs an operation that is not directly visible to the user. For example, downloading data from the servers like images and text. Like, for example, you are using Instagram and you're scrolling through your Instagram. You can notice that images already gets loaded before you scroll there. Or you do not see it loading, like you do not see a progress bar showing it's loading and so on. So that is an example of a background service. Or for example, you are downloading something on Chrome. If you're downloading a file on Chrome, you can see it downloads in background. So this is the example of background services. So that is the thing that service do, that it can run heavy tasks or long tasks in background without the user noticing it. So we can use services in our Android apps to do a lot of things. Now, the next thing is broadcast receivers. So the Android operating system sends different types of broadcast messages throughout our devices. So the broadcast receivers, they do nothing but they just simply respond to these broadcast messages from the other apps or the Android operating system. And these messages are also known as events. So for example, you connect your charger to your Android phone. So as soon as you connect your charger, the Android device sends a broadcast message throughout your operating system. So if any of your app has set a broadcast receiver for the charge to know if the charger is connected, it will receive that broadcast message. So you might know this, and you might have seen several instances of it. Like if you open a camera, there is a pop-up in some apps, or if you connect your charger, or if your battery is low. For example, if you're video calling or calling on WhatsApp, and if your battery is low, you see there is a pop-up on WhatsApp that shows that your battery is low to everyone. So that feature is made using the broadcast receivers. So it receives the broadcast from our Android operating system and it performs the task. So there are a lot of different broadcast messages that you can go through on the internet. You can check the Android developer documentation about all the different types of broadcast messages, and you can make different features in your Android app based on these broadcast messages. So this is the purpose of the broadcast receivers. The next thing is in Android is the Gradle. So the just before we saw the Gradle files in Android. So this is the same Gradle thing. Let me just close this for now. So these Gradle scripts, these are the same Gradle that we're talking about right now. So what is Gradle? So Gradle is a build system that is used to automate building, testing, and deploying our apps. So it is nothing but two build.gradle files. So these are scripts that we can automate for different tasks. For example, for simple tasks like copying files from one directory, one folder to another, can be performed using Gradle scripts. And now you might be thinking that why do we need Gradle in Android? So we need Gradle in Android because we need Gradle in every Android project, because Gradle generates the APK from our Java and or Kotlin or .kt and XML files. So as you can see, there are different types of files in a project. So an Android project structure is very complicated. And if you want to see, I'll just show you in my Explorer. Just 1 second. Okay, so for example, this is an example of one of the Android apps. So you can see the project structure here. And as you can see, there are a lot of different files in an Android app that gets automatically created when you create a new project. So an app file contains a build folder. Then there are releases, source, and so on. And there are a lot of things in every Android app. So in the main folder, you can see there are two types of files, that is Java and resource file. And there is a manifest file that we know. So if you remember, manifest file is nothing but it is a file that contains all the basic information about the app that we need to know, that the Android system needs to know as soon as the app gets launched. So this is the project structure. As you can see, it is very complicated. So if we need to build the Android app from this whole project, so we need to create an APK file. APK file is nothing but the file that we install on our Android, just like we install exe files on our Windows. Similarly, on Android, we install .apk files. So in order to build that APK files, it is not possible for us to build it manually. So those things are done by Gradle script. So it is designed in such a way that all the Java files and all the XML files and other resource folders and so on, all these files, build.gradle folder does is it mixes all these files and renders it and compiles it into an APK folder. So these things are done by the Gradle file. What it does is it takes all the source file, the Java and the XML file, and it applies all the appropriate tools and converts all the Java files into the there are DEX files, and it compresses all of them into the APK that we can install on our Android device. So this is the purpose of Gradle in a nutshell. There are a lot of other things also that Gradle does, but that is not in the scope of today's presentation. Now, the next thing is views. So view is a basic building block of the user interface in Android. A view is a rectangular box that can show data to the user and the user can respond to it. So it is nothing but everything that you see on your activity in an Android app is a view. So view in Java or in Android, view is a class. So in that class, there are many different subclasses, and every subclass has a different purpose. For example, as I told you, view is nothing but it is the UI elements. So the many subclasses of views are these. For example, there is a text view. So text view is nothing but it is used to display text. Then we have edit text that is used to write editable texts in our Android. Then we have buttons and menus. Then scroll view is used to scroll, like for example, you scroll on your Instagram or WhatsApp. It is not generally scroll view. They use recycler view, but scroll view is the basic version of the recycler view. Recycler view is like it is scroll view, but it is more advanced. We will be talking about recycler view on the day 2 of Android study jams. Then if you want to show images in our Android app, we can use image view. And then there are group views. It is also called view groups. There are different types of view groups like constraint layout and linear layout. We will see what these are in just 2 slides. So these are some of the example of view subclasses. So this is a text view, as you can see. The text that we see, like for example, on our WhatsApp, the messages that we see, those are text views. Then the place where we can write message, like the chat menu, the bottommost area where we can write messages on our WhatsApp, or we can write comments on Instagram and so on. Those fields are called as edit texts. These are the places where we can write text. Then we have checkboxes in Android, that is checkbox view. Then we have radio button view that has the radio buttons, just like we have in web development. Then there is image button view. So in many places you have seen when you click on an image, a particular function is called. So that can be implemented using the image button view. Then there is an image view, which is used to show image on your screen. Then there is a button view. So every button you see on Android is nothing but a button view. So these are just an example of some of the view subclasses. And then there are layouts in Android. So layouts are nothing but view groups. So what is a view group? Now, view group is nothing but it is a container for views. So you can store many views in a view group. So different types of view groups. These are the general types of view groups. There are a lot of view groups, but these are the ones that we are going to be using normally. One is linear layout. So in linear layout, every view is stored either horizontally or vertically in a linear fashion. So as you can see in this example, it is a horizontal linear layout. So there can be one image here, and then one image here. Then there is a constraint layout. So constraint layout, every view is relatively locked with one another. So like you can set the relation between them, that for example, there is an image here and there is one edit text here and one button here. So you can set the distance between them, that this image and this edit text will have a distance of 50 dpi, and this will have a 20 dpi distance, and this will have 30 dpi distance. So in this way, if you are arranging your views in a view group, it is a constraint layout. Then we have grid layout. For example, what you see on the profile section of our Instagram profile, you can say, or in gallery. In gallery, you can see every image is stored in a grid fashion. So that is a grid layout. Then there is table layout and so on. Now, this is the whole hierarchy of the Android view class. As I told you, view is a class and all the UI elements are the subclass of it. So you know what a text view is, then you know about image view. The progress bar is the, like, for example, you are playing music. So you see that progress bar, that is this. Then we have view groups. So view groups are nothing but these are the containers that can hold many views, like relative layout, grid layout. You will see a lot of these, and we will see an example of all of these things in day 2 and 3. So in text view, there are different things like buttons, edit text, and so on. So this is the view hierarchy. You can go through every different type of things later on after the presentation, or I can just show you on Android Studio. Just give me 1 second. I'll show you an example. Okay, so this is an example of an XML file of a project that I have made. So if you remember, XML file is the file that is used to design the UI element. So as you can see, this is a text view and it is inside a linear layout. So these two elements are in a linear layout. So they arrange themselves in a linear fashion vertically below each other. So this text view and this text view, they are inside a linear layout. So this whole screen is a linear layout and it is inside a scroll view. So the purpose of the scroll view is the user can scroll down. So as I said, Android comes in different device sizes. So for example, if a user has a 5-inch screen, so it is possible that the elements that I have designed can go out of the screen. So in that case, the user can scroll it. So this is the purpose of the scroll view that we talked about. Now let's get back to the normal screen size. Okay. So then this is an image view. As you can see, I am displaying logos on every different element. So this is an image view. And then this is the text view below that. And this is a grid layout. Hello, can someone tell me if I'm audible or not?
Yes, Rishabh, you're audible.
Okay, thank you. Okay, so these are different types of layouts in Android: frame layout and grid layout and so on. As you can see, these buttons, different buttons that I have, these are arranged in grid. So this is a grid layout. So all these things we will be learning in detail later on from day 3 of the Android study jams, when we start making all the actual layouts and the UI elements and so on. So we will be seeing all these things in detail later on. Now let's continue forward. Then the next topic is Kotlin and Java. Now, as I was talking about earlier, and in Android, you can develop the app using either Java programming language or Kotlin programming language for your backend. So as you saw in the app that I'm making right now, this app I had made in Java programming language. So that's why all these files are .java files. Similarly, if we are having a Kotlin, we are making an app in Kotlin file, it will be a .kt file here. So this is one thing. And the purpose of like how you can choose if you want to develop in Kotlin and Java is that now you can also develop all the features of an Android app in Java programming language. But right now, all the Android developers around the world, and even the Google's Android team, they will suggest you to choose Kotlin over Java, because since 2016 when Kotlin was released and 2018 when it was officially declared as the preferred language for the Android SDK and the Android Studio and Android operating system, Kotlin has a lot of features that cover the disadvantages of Java in Android. So like there are many problems with using Java in Android. So one of the problems with using Java is that whenever I'm coding, for example, so as you can see, as you make more complex apps, your Java file gets very much more complicated and it becomes big. So it is not easy for us to make sure that everything goes very smoothly and so on. And one of the biggest issues that developers face using Java in Android development is the null pointer exception. So if you search about null pointer exception in Java, so it is one of the biggest issues that we face. So many times when we are developing apps and when we run our app to check if it is working fine or not, we get a runtime error due to the null pointer exception. So what causes this error, that is null pointer exception? So this is the problem with the null values that can be stored in strings and so on. So that causes a lot of issues. And as you can see, when you are making a lot of apps, there are a lot of Java files in the project. As you can see, this app that I was making, it has more than 20 different Java files. So it is very hard to trace back that which particular line among these 20 different files, and every file can have more than 200 lines of Java code. So what is causing that null pointer exception? It can be very hard. And even if you know that, for example, even if you know that this function or this intent is causing the null pointer exception, it is very hard to resolve it. So what Kotlin does is, Kotlin has introduced the feature of null safety. So by default in Kotlin, there are no null values. So this is one of the example of things that Kotlin is doing right over Java. Like all the different disadvantages or the bad things about we had with Java in Android, Kotlin is trying to cover all those things. So Kotlin has inbuilt null safety. So values cannot be null in Kotlin. So it completely removes the worry about having null pointer exceptions in our Android app. So this is just one example. Apart from that, as I told earlier, in Android, if you are developing using Java, if you have any experience with Java, you know about threading, the concept of threading in Java, that is allocating resources differently to each process in your app. Or like Android runtime we were talking about. In Android runtime, every app runs as its own virtual machine in the Android operating system. So even though every app is running by itself, for example, let's say about heavy apps like Facebook app. So it is more than 100 MB in size and it has a lot of features. And there are a lot of functions, or you can say it might have more than 200 or 300 different Java or Kotlin files in it. So it can be a very heavy app. It will use a lot of RAM. So to avoid that, we use the concept of threading. So the problem with Java is that if we have to make our app smooth, we will have to use a lot of threads. So it will consume a lot of RAM. So if you are making very complex apps, there are chances that it will consume a lot of RAM or it will crash. So that problem also is solved in Kotlin using a feature called coroutines. So Kotlin had introduced a feature called coroutines in 2019. So what coroutines does is, rather than using many different threads for an app, a coroutine will use a single thread and it will allocate the usage to every thread dynamically. So these are the things that we will be learning more about later on, around like the 4th or 5th day of the Android study jams. So just so you know that most of the different big apps or the big companies. Hello, am I audible? Can someone unmute and
Yes,
just...
Rishabh,
okay, cool. Okay, so many of the big companies have already switched to Kotlin from Java, and even Google is developing all their apps in Kotlin programming language. And as you can see from this image here, even companies like Pinterest, Uber, Trello, Kickstarter, or Zomato, Swiggy, and so on, they are gradually moving from Java to Kotlin. And even like, for example, the Zomato app that is on the Play Store right now. So earlier it used to have 100%, it used to be 100% coded in Java. And we can take example Flipkart. So even Flipkart used to have 100% of its app coded in Java. So later on, they started switching to Kotlin, and the new features in the Flipkart app or the Swiggy or Zomato app, these are written in the Kotlin programming language. And even the older features or the base features that they had in Java, they are deleting those features and they are rewriting them in Kotlin. So from these, you can get an idea that Kotlin, you should prefer Kotlin over Java in Android development. So that was about Kotlin and Java. If you want to discuss more about this, we can talk on Discord later on. So to summarize everything in today's presentation, let's look at all the topics that we covered from slide 1. One second. Okay. So we started with the basic definition of what Android is and about the kernel or the Linux kernel, that it is the interface between the hardware and the software. And this was all about what Android is. Then we took a look at the SDK, the Android SDK. So just to tell you again, with every new version of Android that comes in the market every year, we get a new software developer kit. So for example, let's say we got a new feature in Android 13. So Google showed a new feature that they're releasing with Android 13. And if you want to implement that features in your Android devices, you need to use the SDK that they release with Android 13, because that feature will not be available in the SDK that is there with the Android 12 right now. So this is the purpose of SDK. And then we have the Android Studio, which is the official IDE for making Android apps. So it is bundled with the Android SDK. All the features of the Android SDK, all the libraries are inbuilt in the Android Studio. And there are a lot of more things inbuilt in the Android Studio, that is the SDK for the Firebase also, which we'll be learning later on, what Firebase is and so on. Then we learned about Google Play Store and what is its importance for us as developers to publish our apps on the Google Play Store and the developer console. Then this was one of the things. You don't need to worry if you did not understand it completely, but you need to know the basic information about the Android architecture, or at least the main topics about it. So this is the Android architecture. Then we got to know more about the Android versions and API levels. As you start learning more about Android, you will be talking more about the API level than the Android version numbers and so on. We will be referring to the different versions using the API level only from now on. So then we discussed about what Android apps is, and then I showed you different components or the file structure of Android, different types of files that are available in the Android in the Android project. So after that, we took a look at the different challenges that we face as developers in Android development and the building blocks of Android. We saw this in the Android Studio, and then we took a look at some of the major components of the Android building block. First being the activity, what activity is, and then we took a look at the Android activity lifecycle. So this is an important topic. So later on, we will be focusing more on in upcoming sessions on the Android activity lifecycle. Also, there is a thing called fragments. I forgot to mention earlier. Fragments is similar to activity. We will be talking about it on day 2. So there is services. Now you know what services is. It is just we can use services to run long or pending tasks in background without the user noticing it. Or if we want to get data from the server and so on, we can use service to call those services, and we can do function calls and get those data in our Android devices. So if you want to run anything in background without the user knowing or without disturbing the user, like downloading files and uploading data or so on. So these things are done by services in the background. And there are 2 types of services, background and foreground services. Then we talked about broadcast receivers, what these are, like the purpose of broadcast receivers. They read the broadcast that the Android operating system and different apps tell Android apps broadcast in the operating system. And using those broadcasts, the broadcast receivers can do certain things. Like for the example that we saw was in WhatsApp, if we are calling on WhatsApp and our battery is low, so it gives a notification that the battery is low for that user. So how does it do that? It uses the broadcast receiver to know when the battery is low or when the charger is connected, and so on. Even if you have seen that if you are registering for any new app and you get an OTP, the OTP gets read automatically. How it does that? It also uses the broadcast receiver to read your messages and automatically type the OTP in most of the new apps. Then we took a look at Gradle. Gradle in Android. What the purpose of Gradle is, in simple words, it is used to automate tasks and it is used to build our Android APK. So the APK that we built, it is used for that. Then we took a look at View in Android. So View is nothing but the UI elements that we see in our activities on our screen. There are different types of views like text view, edit text, then checkboxes, radio buttons, image view, image button, and the button. Then there are different types of layouts in Android. We will be taking a look more later on. But this constraint layout is something that comes default in new activities in Android, and this is, in my opinion, this is better than the linear layout, or it depends from case to case. But generally, I prefer to use constraint layout more than the linear layout if possible. Then this is the view hierarchy. Like view is the main class and there are subclasses of the view, so it is all about that. You can take a look at this, and if you want to know more about any type of UI element or view, you can search on Google and read more about it, or you can see the Android documentation on the Android developer website. Then we learned a little bit about Kotlin and Java and why we should prefer Kotlin over Java. And even for the sake of this course, we are going to be doing everything in Kotlin and not in Java. So this was the summary of today's session. Now we will be seeing you on day 2 of the Android study jams. So this was the day 1. The second day or the second session is on 11th of December. That is day after tomorrow. So there is something that I need you all to do, and please try to do it. So go to g.co/android/basics, and don't worry, you will get this whole PPT presentation as PDF on our WhatsApp groups just after this meeting is over. And you can also watch the recording of this whole session on our YouTube channel by tomorrow. So what I need you to do is just go to this link, g.co/android/basics. This is the course that we are going to be completing in the next 30 days. What you need to do is you need to start with the unit 1 of this course. So the first unit is Kotlin basics. So this is the unit that we will be covering on day 2. So on day 2, I will be teaching more about these pathways: introduction to Android, create your first app, building a basic layout, and adding a button to an app. So these are the pathways that we will be covering in the next session. So what I need you to do is I will strongly suggest you that try it by yourself first. So go to this link. You have this whole evening, today's evening, and the whole day tomorrow to try this. And it does not take a lot of time to complete one pathway. It will hardly take, even if you're doing Android and all for the first time, it is very much new to you. It won't take you more than like say 30 minutes for each. So 30 minutes for this, 30 minutes for this, then 30 minutes for this. Even at max, you can complete at least the first 3 in under 2 hours, even if you are very much new to it. So at least try this out, and it will be very much helpful to you. You will be able to understand everything more easily on day 2 if you try it out by yourself first, because these are the topics that we will be covering on day 2. So day 2 is all about learning Kotlin first. So we will be learning about Kotlin in detail on day 2, because that is the programming language that we will be using to make our apps. So that is all about this thing. And if you are not on our WhatsApp group, like either of the WhatsApp group, if you're not in, then you can use this link to join our WhatsApp group. And also, if you want to discuss more about the Android study jams, or if you have any doubts and if you need to talk with me, you can click here and join our Discord server. So on Discord, you can come on voice channel and you can personally one-on-one ask me your doubts, and I can try to clear your doubts. And you can just ping me there and we can talk there about anything development or Android related later on. So this was all about today's session. I will just see the chat if there are any questions, and then we can just conclude. Okay, so if you all have any questions, you can just put in the chat right now. I will just try to answer your questions and then we can conclude this session. Kotlin, I'm not like 100% sure, but up to my knowledge, Kotlin is not used mainly for game development and all. If you want to develop games for either Android or iOS, you need to learn more about Unity engine. So you can use Unity to develop apps. Okay, 1 second. you can go to this link, linktree/DSC PHCET. Here you can find everything, all the relevant links. Also, just one thing I want to tell you. Just give me 1 second. Okay, so you will be getting a message for the day 2 session tomorrow. What you have to do is, just like for today's session, you had to book a ticket. You will get a message tomorrow for the tomorrow's session. You just have to go to that session and you have to book your ticket here. Okay, just like you did for today's session. This is for the people who might have not booked ticket and directly came through the link. Please do this because we need the data, like you have attended all the sessions and so on, for the end of the Android study jam. So for every session you attend, please make sure you have the ticket of that session. So you will be getting the message for day 2 by around 12 in the afternoon tomorrow. So before 12 in the afternoon tomorrow, you will get a message on the WhatsApp groups and Discord server and so on for the day 2. And if you are a member of our chapter, 1 second. Okay, so you can just go to our college page and you can just join the chapter. So if you join the chapter, whenever we publish a new event, you will directly get a mail for that event. So like whenever we publish the day 2 of the Android study jams, that is most likely by tonight or tomorrow morning, you will get a mail and you can directly take your ticket from that mail. So just join the chapter and whenever you get a mail, just go through it. So that's it from my side for today. And please, I will tell again, just try to go through the unit 1, at least pathway 1, 2, and 3 by yourself before 11th December. And we will be meeting again at the same time on 11th December. And the links will be shared to you on WhatsApp. So that's it from my side. Thank you everyone for attending today's session. I would like to call on Sakshi to continue forward.
So as this session comes to a close, I would like to extend my thanks to each one of you for attending and being so cooperative throughout the session. Looking forward to see you all again on day 2 of Android Study Jam session, which is on Saturday, 11th December. And more details will be shared till tomorrow morning or in the afternoon. And lastly, please don't forget to fill the survey form. The link would have been shared in the chat box. So yeah, that's it. Once again, thank you everyone and have a nice day ahead.
Okay guys, just I would like to add one thing. Before you leave the meeting, please fill the survey form that we will be sending in chat right now. And after that only leave, because we need to know the preferred time slots that you prefer for these sessions. So for the future sessions, that is day 2, 3, 4, and 5, we need to know that what time is better for you and you can attend on those time slots. So please fill the survey form that we will be sending right now. Just wait a second. Okay, there is the link in chat. Just open that form and fill it and just let us know what are the time slots that you prefer for these sessions. And if you have any feedback or any critics, please write it in the chat, because it will help me to make the future sessions better. So if you need if you need me to cover any specific topic, or if you want me to go in more details, or if you want me to make it more easy or go fast or slow, or anything or any suggestion that you might have, please put it in the survey form down below. And that's it from my side. Thank you all for attending today's session.
Guys, this session is officially concluded. If you have any questions, you can ask.
Okay, guys, if you have any questions, you can ask in the chat, or you can open your mic and speak, or else it is concluded, so you all are free to leave.